All right. So 4.2, constructing arithmetic sequence. Okay, so what in the world do we mean by an arithmetic sequence? What is that? Okay, very, very simply, all an arithmetic sequence is a linear equation. In other words, it's y equals what? There you go, mx plus b. That is all an arithmetic sequence is. What do we say about math? Same thing in different ways. This is a different way to call a linear equation or a linear function. It's referred to as an arithmetic sequence. Now, I'm going to explain to you why it's called arithmetic, okay? What does that word really kind of look like? Arithmetic. What's the most basic arithmetic you do? What's the most basic arithmetic that you guys first learned? How to what? Add and that's the most basic arithmetic. That is all this whole lesson is. Okay? So, right here they give us the formula. So go to y equals, type that equation in, 10x plus 2. Y equals 10x plus 2. Go to second window, your table set. Start your table at 1. Do your delta tables by 1. And have both of them on auto. Then press second graph to go to your table. And then tell me what the values are here. What's the value at 1?
12.
And at 2? 32. 42. Wait. Yeah, I was going to say, it doesn't seem right. All right. 22, 32, 42. Okay. Now, here's why it's called an arithmetic sequence. What did we say the most basic arithmetic was? Adding and subtracting. Look right here. What is the pattern here every time? You're adding 10. That's why it's called an arithmetic sequence. So you're adding 10 every time. That's why this is, again, referred to as an arithmetic sequence. It's basic arithmetic. What we are doing is we're using a linear function or a linear equation, slope-intercept form, y equals mx plus b. Okay, so let's talk about what is the domain. All right, so again, we had values of 12, 22, 32, 42. Our domain are the x values. Well, what are the x values here? 1, 2, 3, 4. Now, for this problem, in the previous lesson, we did ... at the end to show that it kept going. Well, in this particular problem, we're only doing 1, 2, 3, and 4 because that's the context of our word problem. We only sold 1 ticket, 2 tickets, 3 tickets, 4 tickets. What's the range here?
12, 22, 32, 42.
There you go. Now, since I'm only listing 4 numbers, there's no reason to write a description like increase by 10 or anything like that. If I had 12 numbers to list, then I would probably want to use some sort of words to describe that. But 4, just write the 4 numbers. What is the first term of the sequence? 12, okay? First term is right here. It's whatever corresponds to 1. It says find the difference between, well, we already know what the difference is. It's what we said it increases by, which is 10. Now, what's that 10 represent again? That is our slope. Okay? That corresponds to our slope. Now, again, what is b? We call b the what term? Which is called the zero term. I don't have the zero term in this problem. I have, starting out, what term? Term 1. So if I want to go to the zero term, I go backwards, which means I do what here? I subtract 10. 12 minus 10 would be 2. Well, if we go back to the formula up here, that was why our y-intercept was 2. So make sure you make that connection. How you can look at a pattern in a table and be able to come up with the equation. Now, you can do that only if only if it's an arithmetic sequence. Later on, we'll learn how to come up with formulas for patterns that aren't arithmetic. But for right now, that's the only one you guys know how to come up with formulas for. So now we know what an arithmetic sequence is. The common difference, all common difference is what is the pattern? What's it going up by or going down? If it's going up, it has what kind of slope? Positive. If it's going down, it has a negative slope. Okay. So we looked at the first example of how to write a formula, an equation for an arithmetic sequence. But we can also do a recursive rule. So we've already done the explicit, which is y equals mx plus b. Recursive, again, is always based on the previous term value. So here's how you do a recursive. Very, very easy. Look at the pattern. What is happening here every time? They're going up by 500. That is referred to as the common difference, or we think of it as our slope. To write a recursive rule, all you do is this. Remember, with recursive, what do you have on both sides of the equal sign? F of n. So it's f of n equals f of, instead of n, it's n minus 1, the previous term. That's what that minus 1 indicates. I want the thing that happened before it. Then all we do is say, what do we do to that previous term to get the new term here? What am I doing here? I am adding 500. So all I do in this formula at the end is put plus 500. That's all you got to do. So the book talks about a way to come up with the explicit rule here. I'm going to completely ignore that. We're not going to do it that way. We're going to do it what I think is much more simple. And we're going to go back to what we referred to here. When we talk about the b, we're talking about the zero term. So to me, it's easier to use the table. I want to find the zero term, so I go backwards.
1,500.
Exactly, by doing what? What did you do? Subtracted 500, because if you're going backwards, you do the opposite. And if you subtract, you get 1,500. There is the zero term. That, to me, is a whole lot easier than doing what the book does. So now I could write the equation. The explicit rule would be y equals 500x plus 1,500. And there you go. All right, so we're going to go number 5, your turn problem. And rather than do it the way the book did, we're going to do what we said. So the first thing you got to do is find the pattern. Okay? Find the pattern. So let's look here. What is happening every time here?
It's subtracting by 14.
Exactly. We're going down by 14. Now, what's that minus 14 represent again? That is our slope. Okay? That's our slope, or our m is minus 14. So I need that for 2 reasons. One, to write a recursive, and that's what it asked me to do first, write a recursive rule. So recursive rule is f of n equals f of n minus 1, and then I have to tell what's happening. What is happening? It's going
Down by 14.
So we do minus 14. That's the recursive rule. Then it asked me to write an explicit rule. So now I'm going to use the notation y equals mx plus b. So I do y equals, what is my slope?
14, -14.
Negative 14. So negative 14x. Okay, now I need the zero term. So what I do, I go back up to my table and I go backwards.
You add
So I need to add 14, which would put me at,
169.
there you go, what Adam said, 169. So this is plus 169. To me, that's a whole lot easier than what the book's doing there. Now, technically, this is not right because what is the variable they're using here? N. So really what you want to write is function notation using n. So really you want to write f of n equals negative 14 n plus 169. That technically is the explicit rule because they're using it in function notation up here using the variable n.
So on the test, are you
To the your turn problem, number 7. So the only thing that has changed for this particular example is they're not using a table. But I'm going to make it into a table. Okay, I'm going to make it into a table. So all I'm going to do here is I'm going to write above it what the term number is to correspond. So term 1 is 6. Term 2 is 16. Term 3 is 26. Term 4 is 36. Now, why am I doing that? Because if I want an explicit rule, I have to find term 0, okay?
what if
All right, so the first thing we're going to do, let's find the recursive rule. So we look at the pattern. What is the pattern here every time? Adding 10, okay? So for the recursive rule, it's f of n equals f of n minus 1. And then we put what the pattern is, which is plus 10. Super easy. That's all you're doing there. For the explicit rule, it's y equals mx plus b. Well, we know what m is. M is,
the slope?
which is 10, because we're adding 10. What we need is b, the 0 term. This is why I made it kind of as a table. I've got to go back to the 0 term. So what I do here, I subtract 10. What is 6 minus 10? Negative 4. So now the function, if you do function notation, is f of n equals 10 n, because I'm using n, minus 4, because my 0 term was negative 4. All right, so the last example here. They're not giving us the values in a table. Now they're giving us the values in 2 different representations. A word problem and a graph. You still have to be able to come up with the formula, whether it's the explicit rule or the recursive rule. So when you read the problem, you got to identify the stuff. And this is what we've been practicing in Module 3. It says the cost of a whitewater rafting trip depends on the number of passengers. The base fee is $50. So what is that base fee representing? The y-intercept. Because we referred to the y-intercept as our starting point, starting fee, initial cost. The cost per, again, anytime you see that word per, your first thought should be what? Slope. The cost per passenger is $25. So that $25 is our slope, m. So, should I be able to write an explicit rule here?
Yes.
Sure. The explicit rule should be y equals 25x plus 50. That's the explicit rule.
You can write f of n equals,
So that's a good point, Giselle. So this is the equation, but because the graph is using n and f of n, technically you want to write it using that notation, function notation here. Now, could you have gotten that from the graph itself as well?
Yes.
You could have. Look at the y values here. What are they doing every time?
Going up by 50.
They're going up by 25, okay? That is your what?
Slope.
Slope, okay? That is your slope. Again, we have to find the zero term. So that means I've got to go backwards here. If I go backwards, I need to go down 25, which would take me to 50, and there's my zero term, which is my y-intercept. Now, what we've not done is we've not written a recursive rule. But again, the recursive rule is very easy. F of n equals f of n minus 1, and then what's happening every time? We are adding how much? 25, and there's your recursive rule. Okay, so here's what you're doing. Page 170, you're doing numbers 1 through 3, okay? 1 through 3, all of those. And then you're going to do 5 through 23, odd. Okay, 1 through 3, all. 5 through 23, odd. That's your assignment.